Hi, we're going to do more rules for differentiation. Today, rule 3 and 4, but first rule 3, the constant multiple rule. And this says if u is a differentiable function of x and c is a constant, then this yellow thing is true. Okay? And I'm rolling through this because I'm running short on time today, but what this basically means is anytime you have a number, a coefficient, if you will, multiplying some function, then it works out to be the derivative of the function multiplied by that coefficient. In other words, if we had 7x to the fourth, well, that's equal to 7 times the derivative. There's my symbol for the derivative of x to the fourth. 7 times that. So it's going to be 7 times, and by applying the power rule that we saw from yesterday, that's going to be 4x to the third, because you would subtract 1 off that. And if you're like, what's the power rule? Remember, it's of course this right here for any function that's x to the n. So you would put the 4 down front and subtract 1 off that, making that. So this winds up being 7 times 4, which is 28 x to the third. That is the constant multiple rule in action there. And you'd use it kind of just intuitively all the time. Anytime you have something in front, when you bring this number 4 down, it multiplies that. Okay, so that's how that works. That one's pretty simple. Let's look at this one. Rule 4 is called the sum and difference rule. And there's a whole bunch of stuff with the word differentiable in it, like 4 or 5 times. But this is a great example of where the yellow stuff is much easier than the blue stuff. Okay? And let me try to explain that, of what this means. This says the derivative of a function. I'm just going to paraphrase what's in blue here. The derivative of a function plus or minus, so added or subtracted to a different function, equals the derivative of the first one plus or minus the derivative of the second one. And this makes life so easy. For example, let me show you this. Let's do the green one first. If we are going to find the derivative of this function right here, where it says y equals x cubed plus 6x squared minus 5/3 x plus 16, and it says do dy over dx, which is Leibniz notation for that. If this was f of x, then it would just be d over dx. But we have basically 4 different terms in this thing. So what this boils down to is dy over dx equals d, and I'm going to use Leibniz's version because you guys got to be comfortable with this, x cubed plus, actually let me make that a different color. Let me do, nice. If we do this in a different color, we're going to take the derivative of that, and then the derivative, and this should be in parentheses here, the derivative of 6x squared, and I really wanted that to be green. I am not switching my colors right at all here, plus the derivative, that's all that means, of negative 5/3 x plus the derivative, and that should be, that right there, wait a second, I got a little issue, that should be in parentheses right there, plus the derivative of 16, there we go, and that should be in parentheses. Right, that's a lot of stuff, and you're never going to write this in real life. When I say you're never going to do this, it's because you will figure out that you just do the derivative of each term. So for example, this would be 3x squared, that's the derivative of x cubed. 6x squared would be plus 12x, using the power rule there, plus 5/3 x. Well, we saw if we have a coefficient in front of just x, it just becomes that coefficient, so it's 5/3. And then plus a constant term of 16. Well, if you take the derivative of a constant term, that's rule 1, it just becomes 0. So this is plus 0. So our final answer would just be 3x squared plus 12x plus 5/3. That would be dy dx. And I invite you guys to try this one. And we'll talk about that one tomorrow. See you later.